Hey, John here. Made a bit of a boo-boo on this project. Let's look at what I did and how I want to fix it. Now, some people have asked me if they can go ahead and build this board. I put this big warning on here to let everyone know it's not advisable. It's not that it can't be made to work. I suspect it would work, but this chip here just doesn't fit on the pads that are on that board. As always, I like to appreciate my Patreons, all my Patreons, especially the VIPs. Thank you very much for helping out, making all this possible. Now, the problem with this is that I fell prey to something that I've done before. We have all suffered this. I see this happen all the time. Professionals do this. Everyone does it. It's just a nauseating fact of life. If you don't pay super duper attention when you're establishing the footprints for your project, you're going to end up in trouble. So this is the current version of the footprint in question here. You can actually see that these pads are getting a little strange looking right now, okay? Because I've been playing around with them, trying to figure out what the best size is that I should put on here. Now let's take a really close look at the actual board in the actual Z80. That is the problem. You see the heel of this pin right here is in the middle of that pad, and you could call that the toe, I suppose. The tip of this pin is off the end of the pad. You might say, oh, well, I misaligned it. Well, these look pretty aligned to me, and look at what happens over here. The same problem on this side. The heels are in the middle of the pads, and the toes, the ends, the tips are way off the end. Now, if you used a stencil and some hot air or a hot plate, this would probably be able to sit. You could get it to sit on there. You certainly wouldn't want to do this with a production board. This is just wrong. In reality, the entire pad should be moved out and realigned. So what I did is I used a footprint that claimed that it was for this package, and there must have been some subtlety about it that I missed, or maybe it was never right. It was always garbage. I don't know, but this is really frustrating. You know, you do all this work, you lay out a board, you order it, they ship it, and weeks go by and so on, and then the darn thing doesn't fit. Now, that happens because you don't look closely at the data sheet. You don't come in here, in my case, you is me. I didn't come in here with a caliper or something in the footprint editor tool to figure out where these are centered and, where the ends are and stuff like that. So I'm going to hack this just to make it work in this prototype board. You can see I've hacked the pins over here. They're bigger than these down here. They all four sides used to have the same size pins. These are gigantic, these are sort of medium-sized, and then these are the original small, short ones, okay? Now, what I've done is I've gone into the library and copied the PQFP80 blah, blah, blah footprint here into my library. Let me get out of here. I don't want to actually change the one I'm using. What I want to do is I want to open up the editor, and I want to actually edit the thing. So I've already made a copy of it and put it in my library called the JB Footprint Library. Where is it? There's one called Footprint, but that's not the JB Footprint. There it is. Okay. So I created this library. I went over this in a series on how to use KiCad some years ago. I'm still running version 5. I apologize. I run 5 because this is the official version that's supported on Ubuntu 20, which is the one that I run on this particular desktop because it takes forever to learn how to properly capture the screen in a reliable and reproducible manner to make these videos. And if I upgrade every 5 minutes, all I ever do is upgrade my system, and I never actually get any work done. So those of you that wish I would upgrade to KiCad 7 5 minutes before they probably will release KiCad 8, I apologize. This is just the one that I'm using these days, right? I have used 6, I have used 7, I've got other systems, but I don't have them set up for recording video. So this is the one we got today. All right, now in the editor, if I wanted to spend a month going through here and editing all these values one at a time, I could do that. And that's one way to do this. Another way to do it is to observe that the footprints are actually stored in ASCII files, and all these coordinates and sizes are just in ASCII. You can just go in and edit that file and change those values if you want, and do it in mass with a nice text editor rather than clicking the death out of your screen for an hour and a half. Now, the reason this particular footprint in my setup, my library here today, is in the condition that it's in is because I was talking to somebody on the Discord a little while ago about this problem. He found it out. Somebody on Discord named Dino, who, by the way, ultimately, sent me this updated, his version of my design here, which you can see my original drawing basically in here. He moved down the header that I have above here. Where's my schematic? He moved this down into the right, but this is basically the same thing. And he added some series terminators, which I think are probably a good idea. He's playing around with a reset circuit. I don't believe this is necessary. I'm going to leave it out. He also added some probe pins and some LEDs. And he also wanted some mounting holes so that he could prop the board up and not have it hang off the end of the FPGA host board and then dangle in the air. Probably a good idea on a couple of these things. Now, he also did one more thing. I'm not going to talk much about it. I'm going to make the same change. He's absolutely right. He swapped the DREC1 and the M1 pins here. We'll talk much more about this when we talk about the FPGA that this thing plugs into. This was an oversight on my part. It's probably a whole video on its own. We'll talk about that later, but keep in mind I'm going to reverse these two pins here to head off a future problem at the past. And what else did he do here? That's really it. Not much. I'm not going to put the LEDs on here because I have 8 LEDs on the FPGA board already, and I can simply route the signals I want to see directly onto the LEDs on the FPGA board if I so want to do that. And I don't want to mess around this much today, okay? So what I'm going to I'll probably put the mounting holes in there. That seems like a reasonable request. And I'll add these series terminators. The reason he put these in here, it's generally, bad form to just run CMOS for any great length. And with these boards and the header, and running into another FPGA board and all, that probably would, if you put 33 ohm series resistors on the end of a signal that is the source of it, you're back terminating here, it will reduce the overshoot and ringing and things like that. I'll add a link to a paper from Texas Instruments that discusses this and why you do it and the math and all this other fun stuff. If you want to know more, you can chase that down. The bottom line is throwing in a series 33 ohm resistor can improve your signal integrity. I probably should have put some on the FPGA board itself. I didn't. This is just for hacking, basement hacking type of stuff. This board will probably work either way. The short of it is, without them, the amount of capacitance, the reactance on this connector and all the traces, it can be very high because these are not controlled impedances or anything else. And the current load that's needed to change it from a 0 to a 1 or a 1 to a 0 is instantaneously incredibly high when you have a high slew rate MOS driver coming out of the source end of the signal. And if you put a little 33 ohm resistor in here, what happens is all the capacitance and inductance and all the other junk on the circuit boards is on the far side of that resistor, which causes it to slow down on the far side because you can't get an infinite amount of current through a resistor, say 33 ohms. So it eases the burden on the drivers coming out of the FPGA. I didn't do the CPU in this case, right? On the other board, the FPGA, when it's driving, I did not give it the same courtesy. It'll be fine for the tests and stuff that we plan to do with these boards. When we do a final board, we may look more closely at it and decide whether we officially keep them or not. If they're close together and the tracks are short, it's not as much of a problem than if it's long and goes through a giant header like this or something, okay? So that's why he put those terminators in there. It's good practice for a board like this. Now, while we're in the neighborhood, you see this A20 over here? So I was really lazy when I made this board. I mean, I slapped this thing together. A20 doesn't exist on this part. This is the footprint of a different RAM that is a 2 megabit RAM. We are using a 1 megabit RAM that is the same footprint as the 2 megabit RAM, but in the 1 megabit version, A20 is simply not present, okay? So if you use the wrong footprint and you change the name in here, this pin is wonky. It doesn't exist. And if it did, that's where it would be. So that's why we're not doing this. If there really was an A20 and you left it floating, you'd have trouble. You'd want to ground it or something. All right, let's get back to the number one primary problem here. And that is that the CPU doesn't properly fit on the lousy pads. And it is in both directions, by the way. I only shot this photo here. If you rotate it 90 degrees, these pins will be off as well. You can see they don't look bad, but you can see this one is not exactly aligned where it's supposed to be anyway. And if you move this down, these slide off just the same as the ones on these edges over here. Okay? Now, okay, so why is this looking wonky? It's because I was talking to Dino, sharing my screen and explaining this technique that I use. Now, if you go through here and you edit every single one of these, the position and the size, in order to change them, it's going to take you forever. I'm too lazy for that. Instead, what I do is I go in this editor and I kind of look around and I go, what looks, right? This one here, these are really giant pins, okay? I mean, I made them much bigger. I mean, better 10 tons of overkill than not enough, right? We started with not enough, which gives us a little pad like that. This one is more than enough to solve the problem. And this is kind of a midpoint type of solution. So let's give it an eyeball here. How big is this one? This is in the X dimension 2.3 by a half, okay? And its position is 865 and 92. The position is the center of the pad, by the way, okay? So if I change the size, what it'll do, like over here, oops, I forgot how big the X dimension was. I can go over here, say copy, close it, go over there, and if I change this to X dimension, which was what, 2.3, I believe, right? Yeah, and then I okay that, you'll see it grows in both dimensions at the same time. That's not what I want to do. So I have to compensate a little bit on the position. So the position, I added 0.3 just now to make it match the size of the pin, or the pad on the other side of the chip. And therefore I got to add half that much to the X position in order to move it to the right to get it to where I want it to go. Now you can do the math in your head and you can screw that up, or you can say plus 0.5 times 0.3, and KiCad will figure it out and do it for you. And of course, it helps if you use the right punctuation. I put a comma in there. There we go. Now, as you can see, it's in the right position. And if I come back over here, it calculated half of 0.3 is 1.5, added that to 0.5, and now we're at 8.65, and the X size is 2.3. The negative 9.2 is the distance up or down from this origin here. So that moves it away from this origin here in the Y axis, okay? Now, the reason I did this is I want to get one that is correct, and I can see I did it right. I can kind of visualize in my head the coordinate system and all that, but it's nice to verify, okay? So I want to do at least one pin on each side, and I'll explain why in a minute. So I want the X, the length of this pad to be 2.3. And when we go to the vertical ones, that'll be the Y size will be 2.3, and then the X will be 0.5, okay? So there we go. And these are just so big that it will fit. It's not going to be a problem. So we started with 1.3, and we want to go to 2.3. Now, in doing so, I added an entire millimeter to this, and I need to then add a 0.5 millimeter to that, or subtract it. I don't know which signedness. Yeah, see, oops, I put it on the wrong one. I put it on X. Yeah, always good to talk and edit your schematics at the same time. So it's this one. So what do I want to do? I want it to be plus 0.5. I don't know. Let's see. Okay, no, it's minus 0.5. And I already added it, so now I got a -1, all right? Because I got to account for the earlier 0.5. Now, getting it to the right place in the right alignment is critical. Then what happens is, like I said before, these are stored in ASCII files. We just open up the ASCII file, and I can look at where pin 80 is and replicate the width and this Y alignment value to all these other pins. Real easy in a text editor. Takes forever to do it in here. I did the same thing on pin 64. So 80 and 64 are right. We do one of them down here. How's about number 25, right? So here we go. I'll probably make the same mistake, right? Again, or use the wrong signedness. I guess it's plus 0.5. Yes, I got it. It's good to get one right after. Once you've screwed it up twice, you can get one right. Now I'm going to hit Control S, and I'm going to close this editor because I don't want to have both this editor and my text editor open at the same time. I can just simply go over to another part here. I'm going to go in here and I'm going to say save the library because I don't know what all needs to be saved when editing. I hit Control S when I was on this part here. So now I'm not interacting with the part that I'm going to go over here into a text editor. And edit this way. All right. So again, you can look at the John's Basement KiCad series to figure out how this library was set up. I went over it and found here's where you add the directories where your libraries are and all that fun stuff. You can go find that in that playlist over there. You can see this is the date and the time. Everything else is from a while ago, right? So it looks like I started this in 2019. Let's edit this ASCII file now. Okay, now, if we look at the footprint here, and this is the PC board editor, obviously, not just the footprint editor. We can sort of see what's going on in here. One thing we can do is, you can click and select this part. You can say update footprint. What that'll do is it'll go out to the library, which I just opened up in my Vim text editor, and it'll reread it and update the footprint that is on this circuit board. And it says, oh, what do you want to do? Do you want to apply it? Yes, I do. And then I close it, and we can see this pin here, that pin there, and this pin over here have all just changed their size and centers, which is the goal, right? So the first one's done. Now, I can see when I make these changes, all these are going to come out here and clobber all these vias, and I'm going to have to move some stuff around, which can be really annoying. I should have moved these further away to begin with, I guess. But we can take care of that as we go. But this is the workflow, right? Given what I just showed you here, you can just iterate now. So one of the things I can do is come in here and start editing these pins. Okay, so we go from pad 1 to pad 80 or whatever, right? So let's start by fixing this row up here. So this is pin 64 from 41. So if we go to 41 through 64, and we know that 64 is right and all these other ones are going to have the incorrect center and the incorrect, in this case, the pad length, right? And this part is rotated on the board, so I got to do all this in my head. What I'm really adjusting here is the X size of the pad and the Y size for the center. So that was what, 64 was supposed to be good, and all the other ones are too small. So if we go down here to pad 64, so you can see that all these other ones are 8.5. This one's 865. And then when you see this is for the X dimension of where the center is. So if I come in here and I just add a bunch of 6s to all these, up from, what was it, 41, I think? I hope, yes, okay. Now, if we just do that and nothing else, what we've done is we've changed the centering. So we should see all the pins move a little bit. Then we'll come back and fix the size. And the size of 64 is correct at 2.3 and 0.5. So all these need to have a 0.3 added in there, right? So I'll do 1. So 63 and 4 should be right, and all the other ones will move, but they'll not yet be the right size. And we'll have to come back and add those 0.3s, okay? So let's go ahead and do an update. Again, you don't need to do it this way. You know, just as easily. You can just peck away at all the pins one at a time and change their values in those editor boxes. And you can see this is definitely what happened. So 63 is the right size, and all the other ones moved up, but now they need to be increased by 0.3 millimeters in this dimension here in order to be the right size pad. No problem. All right, so 0.3. Go up and repeat the oops. You want to not edit it. Again, it's kind of hard for me to do this and talk at the same time. 0.3. You want to do this while dogs are barking or someone's nagging you to take out the garbage or, you know, whatever, you know. You need to be able to focus. 47. This is 46. And 41. Okay. Done. Select it, update it, apply it, close it. Yeah, baby. Now we got to do some cleanup here. Those vias are okay. This one is okay. Looks like we got some unused pins over there. But D7, I mean, would this work? Yes, but I don't want to do that. The reason I don't want to do this is because there's not going to be enough thermal relief on this particular pin, which would totally peeve me off when I'm soldering it. So I'm going to select it, I'm going to hit D, and I'm going to drag it. The resolution on this is really bad. What do we got? Oh, it's a millimeter. Let's move it to some fine green. Okay. Woo, there we go. Select the via, hit D to drag it. And now I can drag it wherever I want it to go. Let's see here. Let's go over there. Drag this whole line up. There we go. Save. I'm going to hit B because I know I got a filled polygon in there. If we turn on the polygons, you can see them. I'm on the front view. Here's the back view, right? Because I did a report of that copper, right? Okay. Turn these back off. So that row of pins up there look good, right? Now down here I got 25, from to 40 it looks like. And 25 is right, and every pin up to 40 is wrong. So let's go find, ooh, too much scrolling. 25 is right, the rest are wrong. So what did I do here? I went from 1115 to 65, as you can see right there, okay? So all these 15s got to become 65s. Which makes sense. We're moving it a 0.5 millimeter so that we can increase the length by 1 millimeter, which goes half in each direction. I mean, optimally, this particular footprint should probably be rethought of in its entirety and use one of the footprint generators maybe and recalculated based on the heel spacing and so on. But I thought I'd just show everybody how to do this just for fun if you run into this weird situation where starting over isn't really a reasonable thing to do. or at least it takes too long if you should decide to try it. What did I say? Up until 40, right? Because 41 is where we left off on the other ones. So this now should update pins 25 through 40. These should all be, and I missed one, didn't I? Let's go ahead and leave this one broken so we can see what we did in here. I mean, you always got to check your work, right? Apply, close. So one of them, that one right there, is the one that we missed, of course, right? So these all look pretty good, except we need to move all those vias, reroute the board. We'll do that later, but there's the one that we didn't get right, which is this one right here. Now we're good. Grab it, update it, apply it. Okay, so these are all now like giganto pins on all three of these sides. Now we're going to come down here. 80 is good, and we need to replicate that down from 65 up to 80. So 65 through 80. Okay, now that's another one of these 1115s. And they need to be made into 1165, like down there. So all these, again, need to become 6s. If you're a Vim aficionado, you can put a search in here like .15. That's probably the only 15 you've got in here. And then you can probably do it like a C, I'm going to say capital W to a .65. Escape, next. Dot, next dot, next dot, like this, and you can go much faster, or you can do it blindly. And now you got to be careful that you don't do stuff that's not what you meant to do. So I'm going to go back to where I left off here, right? Use whatever text editor you want, whatever technique you like. And again, we got all these 1.3s that need to turn into 2.3s. So again, I'm going to search for this one \.3 because dot's a special character. And then I'm going to say R2 and to go to the next one and hit dot to repeat and go on my merry way. There we go. They're all done. The whole thing is done at this point. Let's go ahead and reload. And if you're not yapping and recording and fumbling with your microphone through this process, I missed this one, 65. Then this usually goes a little bit faster. What did I miss here? 65. Yeah, I missed one. And that 65 looks good. Okay. Back to the board editor. Now, of course, you don't want to hack up the footprints that came with KiCad, even if they're wrong. If they're wrong, I simply abandoned the use of them. The reason you don't want to mess with those is because if you ever upgrade your KiCad install, it'll overwrite your files. Never edit something that came with a distribution of any tool. And if there's no other way to configure it but edit the files that they gave you in the place where they gave them to you, then get another tool. Because that just shows that they have no respect for you, the user. They wrote this code. They hacked it together as quickly as they could without any real concern of what the actual cost of ownership of that product is. I can't stand that kind of software. Just don't use it. It's a waste of your time. Life is too short to tolerate someone's crappy software. Okay, now I selected these two parts and these vias around it, and I accidentally selected this track, so I'm going to hit what I'm going to do, I'm going to hit Shift and single click with the left mouse to get rid of that track. I'm deselecting the one track. Okay, that looks okay. Then I'm going to hit M to move it. Now I can slide it around if I want. And you can see it's going to bump into that track, but I don't care. I'll move the track later, like now. If I select this track and I hit D to drag it, the design rules of making sure that it doesn't get too close will kick in. But you got to make sure that you're looking at what else you're beating up when you move this in your schematic. So I just moved this part, right? So what it did here is it probably adjusted the end over there. That's fine. If I drag it even more, it'll start shoving all this around. If I dragged this, it would have actually probably extended this and shoved it as well. I probably should have used D instead of M when I moved it, but you know, whatever, that's fine. I'm going to hit D for this so I can relocate the one end of this onto that via. All right, so now we're good there. This is saying it's not connected, and the reason is if we turn on the polygon fills, I haven't redone the polygon pores. All right, so this is all like connected totally wrong. You can see it's all shorted out. So I'm going to hit B to redo the polygons. That is now fixed, okay? So this is now better. It's connected properly. That via was probably connected to the power plane inside the board on layer 2 here, because it was probably, you know, the old via was over there, the new one's here, and it probably shorted it all out. That would have been a design rule. Check failure anyway. And these other ones are failures as well. You don't want to put vias on the pads. You can, but, and I've done it before, but it makes it harder to solder. It's just a little more frustrating. If you don't need to do it, then don't do it. So I wasn't thinking while I was yakking. This here should have been, I'm going to hit D to drag it over here. It should be away from that pad. So we get some thermal relief. A9, I'm going to turn off the polygons so you can see what the heck I'm doing. That's obviously on the back side of the board. As, what's up with D0? Why is there a D0 via there? And it's on the, wow. That's probably just a screw up on my part. Let's look at the back of the board. There's nothing going on with D0. This whole via is stupid. Get it out of there. Oh, I wonder. How does it go to the RAM? Oh, it must go down this way. Wow. So that was a design update. It probably used to go around this way, and I changed it. And I left the via sitting there. Same with D3 here. Boy, I'm a slob. Bad Johnny. Okay, get rid of this extra garbage. Yeah, okay. I don't need both of these ground vias. The reason I put this other one over here was to make, you know, to get it closer to this bypass capacitor and into the power plane inside. Probably not a bad idea. Now, A19, I don't know if I left enough room for this thing here. Let's see what happens. I want some thermal relief. Oh, boy. You don't run it underneath the... you see what the router is trying to put it through here? That's like really a bad thing to do. What I should do is just move all that further over. I'm lazy. I'm not going to do that. And this is just a proof of concept board to test out this thing anyway. So what I'm going to do is I'm going to move the via underneath the chip over there. For A19, it's going to be fine. This is garbage. I don't like that. Let's drag it up over here. Take a look over there. Make sure it didn't bang into something when I was screwing that up. Okay. Grab this one. Drag it out here. With A14, and you can see A15 already went to the other side anyway. What am I doing? Oh, I got to select one. I'm going to go D to drag. There we go. And here's A13. Drag that out of there. All right, I could probably put A15 in here. I'm going to leave Sleeping Dogs Lie. Not mess with that one. Okay, so let's get these other ones out of there. You know, like I said, you don't want to, unless you have a good reason, don't put the vias in the pins. Don't put them too close to the pins either. I do that every now and then. If you have no room, you have to do it. If you have room, don't do it. It just makes all this soldering so annoying. There's one or two of these on another board on the FPGA board that this plugs into. That is just annoying to have to heat up the pad all the time when you're doing this. Come on, let's go. Why can't I do that? I have to hit M to move it. I guess I just threw an extra via here, I guess for good measure. Okay, that's great. You know, to stitch the ground plane inside to the one on the front. Okie dokie. Now all these are going to get screwed up, because once I do that, it's going to push this down. Now what I want to do is I want to kind of keep this relatively neat. So I'm going to just move these out of the way. My hand. Oop. M1 is one of the tracks we're going to move later. Anyway, by the way, right? This out of the way. This out of the way. You can see that it's rerouting these. I want to see what it did on the other end there. It's okay. It didn't like run into something else weird. Let's zoom out and do this one while we're looking. Probably won't do much. Oh, it did. Okay. Decided to peeve me off. You know, if you got space, don't put these rammed up next to each other. I mean, again, without a good reason, don't do it. Because you'll get crosstalk. You'll get more crosstalk than you do if they're further apart. All right, now to swap the, what was it, M1 and DREC one, I mean, this is going to be real easy, right? I'm going to grab, you know, a piece of track here, delete these track bits out of there. I'll delete that one, grab this. I can hit D, and I can start dragging it, and I could, well, sometimes you can actually go ahead and drag it all the way. I'm going to just go ahead and lay a track down. And, oops. I can't. That's why I didn't want to go there. I have to go back to the schematic and reverse the pins here, right? Because the design rule, the validation logic won't let me connect it until the schematic has been updated to show that these pins need to be connected the opposite way. All right, so good. So this takes care of the footprint problem, and I moved all these vias out of the way. This looks pretty good. Right? A close eyeball on this. I mean, you don't want to screw this up. And the next thing you know, there's a stupid via right there. I mean, the design rule will get rid of some of the mistakes, but, you know, thermal relief is not something the design rule checker does us any favors on, at least in this version of KiCad. It doesn't. That all looks good. So I'm going to redo the polygons. I'm going to save it. I'm going to grab, I should have two unconnected nets because of the M1 and the DREC. Track too close to pad. Oh. What's he upset about? Yeah, see, there's another one of these angle jobbies. When I made the pins longer, this no longer clears. Okay, so design rules are always my friend. You just always run them. This is kind of annoying because these will bump into each other, and then all this stuff will start flying all over the place. Now, I could probably get this, I could slide it down a little bit and get it out of the way, but when I need to I don't know if I can actually move, oops, I clicked it wrong. If I select all these vias at once, I don't think I can hit D and do them all. Of course not. I have to do one at a time. I can do an M and move them all at once, and then I got to go back and mess. Oh, jeez, that's terrible. I hate it when it does that. I am going to hit M, and I'm going to just use the down arrow and slide it down a little bit. Okay, and then I'm going to enter to finish it. Same with this guy here. M and move it down. Select this one, hit M and move that one down. Very frustrating. Yeah, so, you know, what's the moral of the story, right? You got to always check your footprints, even if you get them out of the library and they are allegedly the right ones. You know, everyone's not out to help you all the time, you know. Someone made that footprint to solve their problem with some chip that maybe it even fit on. I don't know. Here we are. Okay, now you can grab this and you can hit D and slide it down without all this stuff jumping all over the place. Hit B to report your polygons, save the file, rerun the DRC and clear the markers and start over again. Okay, nothing's shorting out. Unconnected items. These are going to be these two things here that I left unconnected. And we got to go over here and swap them around in here. Otherwise, the PC board editor won't let us connect the traces the other way around. I'm going to rotate it around. You see this, the handle over here? If it lines with this one, then the little highlighting thing goes away. These are all aligned left, and these are all aligned right, obviously, right? So I'm going to save the schematic here. While we're in the neighborhood, I'll redo the design rule check. Ooh! Well, this might be because of the this connector. It's probably like a power pin or something like that. Where's the marker? Oh, there it is. Yeah, so it says the ground is not being driven and so on. It probably says that about power somewhere as well. Oh, there it is. It's microscopic arrow right there, yes. So the two power pins have these DRCs. You can either ignore it or you can put flags on there. I think I talk about this in one of the videos in KiCad. I'm going to put power flags on so that it quiets this down. I like my projects to have absolutely zero design rule check warnings, errors of any kind, because then what happens is you're not in the habit of just ignoring them all the time, saying, well, it doesn't matter, and then later on you find out you missed one because you were too busy ignoring them all. It's just, no, that's just unacceptable as far as I'm concerned. Now I'm going to just say copy this. I'm going to rotate it around, put one down there, hit save. So I was, geez, boy was I a slob when I made this design, right? I didn't put in the back terminators. I didn't really check the footprint for this. Sometimes you get away with it, and sometimes you don't, right? What's the line? Sometimes you're the windscreen, and sometimes you're the bug, right? Sometimes you're the Louisville Slugger, and sometimes you're the ball. And in this case, I was the ball. Alrighty, so let's go ahead and grab the PC board updates from the schematic, and you can see in here it says I changed the name of this, that, and the other thing. Okay, those are now swapped around. I can go in here now, grab the track. I can hit D to drag it. Oops, I didn't want to do it. Sometimes it drags it in a weird way. It's really annoying, so I'm going to just run a track there. And now I'm going to go to the back of the board here. I could probably do it from the front anyway, but I'll do it from the back and drag that one in there. And there's no reason to go out there and turn around and come back. Save that up. Now, we've reversed these two, and the reason we did that is, like I said before, this was once we get over to the FPGA, this pin here can be used as an input, but this one over here on the FPGA can only be used as an output due to some other stuff, due to the way I designed certain parts in the board. I'm wondering what this little line is right there. What's up with that? Is that part of the drawing of that socket? Oh, it is. It's part of the name of... Boy, that's confusing. It's the bar over the M1. I thought it was some weird artifact in the circuit board that I would have to track down. Okie dokie. While we're in the neighborhood, we are no longer Rev 1.0. This is Rev 1.1. Sometimes I put that on both sides of the board. We'll see that better in the 3D viewer. If you hit Alt-3 and open up the 3D viewer, there's our Rev 1.1. There's these enormous pins coming all the way around now, which will be a little easier to get the part on there. Like I said, the RAM looked okay to me. This looks okay here. These are very close, but there's enough thermal relief before we get to that pad, I hope. Otherwise, I'll have to heat the board up more. And when I do the soldering, which is, that's what gets annoying. So the series terminators end up over in here if and when we put those on. I'm kind of torn. Maybe, 50-50. Do I put them in there? Do I not? I just want to get the darn thing to go. It will work without them. The question is, could there be noise? What would happen if you let it run for a long period of time? Would there ultimately be some sort of problems? Same thing actually would probably hold true with this RAM, with the data bus on here, because the data pins are all connected to the FPGA as well. This whole thing could be problematic. All the address lines coming out of the CPU, all these pins have this basic problem with the fact that it's going through this uncontrolled impedance of reactance in this giant connector over here. I'm inclined to ignore it. I did before. I'm inclined to ignore it because I don't want to mess around and reroute the whole board and kill another hour, because I'm sure it'll work without it. So I'm going to let that one go. All due respect to Dino, he is correct in his recommendation, and I am lazy, I confess. I'm going to move these a little further away from the pads so that the heat has a little bit more somewhere to go. This will probably haunt me as well. Let's make it the same size as that track there. How big is this track width? That's 0.25. Let's edit this and make it 0.25 as well. There's another section here. I'm going to just delete that, go back here and drag this over to there. Give me some more relief on that one. Alrighty. Turn on the polygons. I hit the wrong button. I don't know what I hit there. What's that thing? Air wires, I guess. Okay, so I want to make sure that, when I did the fill, that this via here looks okay. That's a pretty fat trace on there as well. This may be a difficult pin to get the solder in, but I think it'll be okay. All right, so with that, we've pretty much wrapped up what the critical items are, and I've lazied my way out of the other items. The back terminators, for example. Reversing the M1 and DREC1 were going to be very useful down the road, and the pins, that's just a showstopper, very annoying. Pins on here worked out okay, got lucky on that one. We're okay in general. Future foreshadowing. I got 3.3 volts on these pins right next to the ground. So, probably not a good idea. You could easily hit a probe here and short these two together and short out your stuff. Probably would be a better idea to put the 3 on 19 and 20 here and skip these pins and leave ground there. I'm not using them anyway. I'm going to leave it. I'm going to leave enough alone, but you've been warned. When you clip a lead on here, make sure it's got some insulation on it, or it's not of the variety that could swing around and knock into the neighboring pin. If you're even going to use jumpers or cables or gator clips are usually what kill me on things like this, you have to be very careful that they don't spin around and touch the next door neighbor pins. What else are we going to do? Well, we'll go ahead and honor the mounting hole request. What do we do for that? Well, you go in here and you place a hole. There's some mounting holes. Mounting hole with a pad, and so on. I'm going to just put a mounting hole. This is what I usually use. And I'm going to just put two. I'm going to put two on the board. Where's a picture of my board? Here we go. I'm going to put up here and up there, so you can use it as a standoff to hold it up. in the air. I'm not going to put any down here. I mean, I'll go ahead and put 2 down here as well, simply because there's room. And simply because someone asked, I guess it's no skin off my butt. If I put 1 on here, I can put 4. 2, 3, 4. Okay, so this is going to be hole 1, hole 2, hole 3, and hole number 4. I hope they have them in stock. At least make it look halfway decent, right? Okay, save. Then, oh, I made a mistake. I should have done the footprint first and then copied it, so we don't have to repeat this over and over again. So what do we got here? If we pick, there are mounting hole footprints that have the right size, you know, holes and stuff drilled in them. Footprint mounting hole. There we go. 2.5 millimeter without a pad, just like this would be fine. At 2.5 millimeter bolt is a common size. Now I can't remember if that's a 2.5 millimeter hole or a hole for a 2.5 millimeter bolt. So there's one. What do I want to do? What I do is I just simply go in here and I copy the whole thing. Control C. Go down here. You can Control V your way through here like this. Or you can edit all of the stuff at once. Where's the mounting holes? Down here. H1 and 2. 3 and 4 already have... this doesn't have a footprint. The other ones do. So you can go like that. Now all of them have the footprints all together. Now if you open it again, it should have consolidated all 4 holes into one line with that as the footprint. Okay. Save it. Go back to the board. Grab the updates. Update the PC board. And hit close. Now what I want to do is I want to know how big the hole is. I grab the caliper. I don't remember how this works. How big is this? Is this... That's a 2.5 millimeter hole dimension. So what I'm going to do is I'm going to go ahead and change this to use a 3 millimeter hole instead of a 2.5 millimeter hole. Because I got a bunch of M2.5 bolts and I don't know if they'll fit. Ooh, a 2.7, that's a great size. How about that? What are all these other things here? The ISO this and blah, blah, blah. What's the difference between the ISO pad and the regular pad? They look very similar. What is the size of the... Can I not edit? I can't see the size of the... Whatever. I'm going to go to 2.7. Hole 2.7M. Oh, I see. Here we go. Here we go. I misread it. I didn't make the screen wide enough. Look at that. If you look more closely, that's a 2.5. This one says 2.7, 2.5. And that probably means that it's 2.7 for a 2.5 hole, bolt rather. So, I mean, it doesn't really matter. I mean, you can stick any old thing in there you want. I just want to make sure it's big enough to hold the kind of screws I have lying around. So let's go ahead and copy this to all the other ones. Hit okie dokie. Save it. I'll come back over to the board and update the board. It says I'm changing it to these other things. They'll be slightly larger, which is fine. Now, hopefully they'll fit, and we don't have to, like, dork up the whole board. Yes, it'll fit. Now, I'm going to get a grid so they can somewhat align, so they're not just, like, all over the place. I'm going to go to a 0.5 millimeter. That's probably a reasonable thing since the board was designed with 1 millimeter spacing for the outline originally. Where do I really want to put these things? Let's go to a 1 millimeter grid. more coarse. All right, oops. Move it around. Okay, it won't do any harm there. Let's get mounting hole number 2. Keep it in line with this one and stick it over here somewhere. Of course the board's not big enough. We'll have to make the board bigger. Just no big deal. We'll drag the end out. Hole number 3. Move it down here. Same general idea. I don't know if they're going to be aligned or not. Sometimes if you do this, you can grab a box and kind of see, or what you can do is type edit, and the X position's 101. The X position on this is 101. Okay, so these are aligned vertically. They look about right from the inset from the end of the board is about right, kind of like little Mouseketeer ears on there. The same sort of thing down here, a little further away, but I'm not going to lose any sleep over it. Then I'm going to move this one down here and do the same thing I did on top. Make sure that we have the correct up and down location. I don't know, it goes over here somewhere. Play the same game. Edit. Oops, that's the open source logo thingy. We'll move that over there. Edit, what are we on here? The X is a 147. About the one up here, that one looks further to the right. 148. That's 1 millimeter further to the right. Okay, if we're going to make the board bigger, which we can, still stay underneath the cheapo prototyping rate. So that's be 149. I'm inclined to want to go to 150. Nice round numbers. Is that right? That one is 150. I think that one went too far. This one's supposed to be 149. Okay. And I'll just move it over. Done. Move it like 150. Okay. Now, these polygon edges you can see here are probably not, they all need to be moved over in order for the copper to cover the whole board, which is annoying. So I'm going to grab this dot over there and I'm going to drag it over. These are all, much larger than the board anyway, in order to make sure we get the full bleed to the edge of the actual board. With copper, that's fine there. Now we can drag these ones out. Not sure is that square? Yeah, that looks good. They don't really need to be square either. They just need to be, able to ensconce the whole board so that we have, there we go, enough copper to get to the end of the board. Bring this over to there. Oops. Come on. This one over. Okay. Now, what I'm going to do is I'm going to grab this line and that arc on the end of the line. So I'm going to grab this line here. I'm going to hold down Shift. Grab that arc. You can see it's lit up a little bit. Come down here and grab this arc down here. Okay. Now I can type M to move and use the arrow key and just move it to the right and eyeball it. It doesn't really matter what size any of this is. Then I can type what M to move that and drag it over and reconnect it. Oops, get the end of the... Come on, where's my... There it is. Reconnect that one. Now I'm inclined to want to move all those vias and even the writing. We take, what am I doing here? If I select them all, it'll be this is going to be annoying. Some of these won't want to move. You know what? I'm going to move the writing and I'm going to leave those vias where they're at. Because I'm going to be lazy. Of course, you don't want the vias in the mounting hole. Just delete it. End of problem. This one here can go too. Again, these vias only exist to connect the outside ground planes to the inside ground plane. And that's good enough for my project here. Go ahead and put this up here. Maybe it'll look better. I don't know. Save it. Alt-3. Give me a, what's this thing? Oh, cannot determine the board outline. That's interesting. So that means that one of the lines didn't mate in the corner. This is a good, nice little test. Let's close this back up. We do the design rule. It probably should say the same thing. Let's delete them and then run it again. Yeah, I don't have a closed polygon. What happened? Oh, when I moved, look what happened. I thought I was dragging the end of that line, and I moved it to the right. I moved the whole line. I didn't, just move the end over. Let's double check. Yeah, okay, so that one's connected on both ends. Oopsie daisy. I did that on both of them. I didn't do it right. I must not have grabbed the dot. I probably grabbed it from here, So there we go. That's now in there. Zoom out and double check over here. There's good. Save again. Alt-3. Ooh, that's still got that big white. Oh, you know why? That's the copper. If I type B to repour the polygons, the copper should stay inside the board. Now, it didn't have the entire board outline, so the copper flowed out outside the board when we viewed it here. Okay, so we got this. We got some mounting holes. These are, I usually like to change the solder mask so that the copper and the mask and everything is pushed away from the hole. And the reason I do that is if you actually put a bolt in here. Now this is, as it is, this is pretty crappy. There's a mounting hole, all right. But if you use it, you're going to have to put like an insulation, plastic washer or something like that on there to prevent a metal bolt from grinding through this solder mask and shorting to this ground plane. Unless you don't care, and quite often you don't care that much about the ground plane because usually the bolts are connected to ground. Anyway, but that is really annoying. I also don't want to see the H1, 2, 3, 4 on there. I invariably go and hide the part numbers from the legend here. Turn those off just because it's ugly. Turn them off. There you go. Invisibilize them. Now, what you can do here is you can say, I want to select, what do I want to do? I want to take this and I can hit, I think, E. There you go. Then you can come in here and you can say, edit the footprint. Now, the problem is, do we want to edit the footprint that is on this board, or do you want to edit the footprint that's in the library and then for all future boards? So if you want to do the library, what you want to do is what I did with the CPU, and that is make a copy of the footprint and put it in your own library, because you don't actually want to edit the library that comes with KiCad. But if I hit edit footprint, what it will do is this will edit the footprint that is on this specific board in this particular project. So inside here, I think, what do? I take the pad, and I say edit, and then inside here, see where it talks about the mask and the shape, local clearance, pad clearance, solder mask clearance, and stuff like this. So if you set the solder mask to like 1 millimeter, okay, you can see in here that it is going to spread that out. Now, you also want to set the clearance for the copper. Let's just do this and save it. All right. Now I've edited that one footprint in that one corner. I'd have to do the other 4, but let's go ahead and look and see what happens in here. So what I've done so far is I've gotten rid of the solder mask back an extra millimeter here. What I want to do is move the copper back even further, and in fact 1 millimeter is not really even enough for this anyway. You probably want to go to almost 2, because you know your bolt head or whatever. If you're going to actually put a bolt through this, you don't want to be grinding up the solder mask, and you don't want to be shorting the ground, etc., etc. So inside here, what do you got? Pad, solder mask. Let's go to 2 on this. Paste clearance, doesn't matter. Where is it? Connection. Thermal. This one here must be the copper clearance. So I'm going to go to 2.5. Got to make it bigger than the mask, otherwise the copper will go all the way up to the mask, edge of the mask. Repour the copper. Let's see what it did there. Turn it on. Okay, there you go. See how the copper's clear now? It won't be clear over here because I didn't add that extra clearance, right? So the copper, you can see, is clear all the way out to this little yellow line here, and the paste clearance will be to there. So if you look at it now, what you've got is bare FR4, and then you've got the mask, and then you've got the copper in there. And you don't want the copper going all the way to the edge of this mask in here, because the very end, the little thin edge of that copper will be sticking out, and it could cause you problems. Now, this is gigantic amount of clearance on here, and it's gone so far as to actually interfere with the ground polygon on that track. I don't care. That's fine. If we look at the other ones, all these look like they will clear in the same amount of distance. So I'm going to go ahead and do that and be consistent. This is enormous. Maybe I should have gone to 1.5 and 2 instead of 2.5 or 2 and 2.5. But that's okay, right? Pad here. E to edit, and remember I'm in here, and what did I say here? I wanted to go to hole 2 there, and 2.5 on this one. Okie dokie. Do all of them. Oops. This is enormous. Come on. Pad, I don't need to edit the text. There we go. 2.5. This one. And here and say 2.5. 2. I did it backwards, didn't I? Oh. There we go. 2.5 and 2. Okay. B to repour the polygons. Now it's griping because these aren't actually connected to anything, so I'm going to go ahead and just delete them. Don't need them there. Anyway, these are grounded, and this connects through. This is massive. Plus, I'm going to have solder in there and pins. Tons of stuff. Now, underneath there, there's some text that I'm now probably interfering with. What I got here? Front copper, back. Where's the silk screen? Yeah, so I now have silk screen in there. And the silk screen is usually going to be trimmed to the solder mask, so it would cut the R off if I had this made. It depends on what settings you have when you generate your Gerbers. But usually the silk screen is going to be trimmed to the solder mask so that you're not printing on your copper by mistake. So there's a little line right there I don't like. What is that? Is that the back? Oh, yeah, that's really close. We don't want that. Now, I'm going to just move it up a little bit. If I drag it, hopefully the newer versions of KiCad will improve this, but look what happens if I drag it. It's going to do this weird thing where, like, in order to get around, let me turn off the polygons. It'll be more obvious what's going on here. Give me some better grid. I got a really coarse grid right now. Okay, there we go. If I hit D to drag this and I start moving it, that's not bad. But once I start hitting stuff, notice it goes up and down and up and down. It's like, that's not a really intelligent way to drag this. I think that'll be okay. I can, now that it's broken, I can, into pieces, I can drag this up like that. So let's do that now. Okay, this is a marker that'll go away when I redo the design rules. I report the polygons, take another look at the polygons. And again, I'm looking in this hole to see if I see anything. Here's another vid that's now a problem. To see if I can see anything like text or something shining through. Is there something that's misaligned? You know, when we do this sort of thing. These are the layer on the mechanical layer notes. Let's see here. Comments, eco, edge, margin, fab. Yeah, that's like the fab notes. So if I just turn that off and get it out of the way, you don't really want vias like this right on the edge there. That'll look bad. That'll look bad. Of course, bad is not having any useful termination, I suppose. All right, let's go ahead and redo this. Delete all the markers, rerun the DRC. Refill the polygons as needed. Unconnected. Is there anything that I left undone? No. Oops. I wanted to hit close, but that's fine. Simple board goes quickly. All righty. Now when we get the board back, it'll have these big gambus holes. So you can put bolts in there if you want to. I don't plan on doing so. And the size is still underneath 100mm square, so you can still get the cheap deal. And these pads are so big. They're gigantic pads, so this should be no problem soldering, except for the silk screen on the pads. Wow, the DRC did not catch that. I'm surprised. Silk screen on top of the pads is usually a pretty standard type of an error to check for. But if we ran the Gerbers, it'll be removed anyway from the silk screen layer. Sure of that. But it should have warned me. That's pretty bad. I probably have the DRC rule set in some weird way that says don't bother checking that. Or don't consider it an error worth warning. Okay, so I updated this board to say 1.1, and what you can do, is it board setup? No, it's not in board setup. We need to do that in the this one here, the page setup thingy. Yeah, I don't have anything in here on this drawing. I'll go ahead and leave it blank because there's actually like a title block down here that nobody really sees or uses, okay? I can update this. What I'm really thinking about, though, is the title block on this page. This says 1.0, and this is the one that needs to be updated. Say okie dokie, save. Boy, I didn't even put my usual disclaimer license thingy in here, so whatever. You can use it. This is just a throwaway quick test board to make sure that I can actually run a Z8S180 and hook it up to a FPGA and make this all go. And to that end, Dino, when he was playing around with the schematic, sent me a note that, you know, in a flash of inspiration, not only did he tweak the board and make one and have it shipped over and put it all together, plugged it in, and started writing drivers and stuff for the FPGA because he's already got experience with FPGAs and stuff like that. And he ported the 2057, or rather the CPM project that I've been working on for the last 2 years. He updated the BIOS and everything else, and he has his running, he said, even with SD card and all. So this is possible, and I'm sure this will run, even with the the non-optimal engineering that I'm doing here just to get the thing to go. So that should be some proof that there will be light at the end of this tunnel. All right. So I just wanted to let everybody know that I am updating the CPU card. I'm going to go ahead and order one like today, right after I shut off the camera here. And I'll probably get it in a week or so and try and put it together and see if it comes to life, see if it works. If it doesn't, maybe we'll be back here adding Terminators or something. I don't know. Anyway, thanks for watching. We'll see you next time.